हेलो स्टूडेंट्स, एक क्वेश्चन देखते हैं. देखिए राइट, इस क्वेश्चन में क्या है, बार मैग्नेट विथ पोल्स 25 centimeter apart and the strength is given 14.4 ampere meter rest with center on a frictionless pivot. Okay, so let us take a bar magnet is there. Right, let us say the bar magnet is given here. Okay, let us, like, I am calling this length as 2L. Okay, so the 2L is given, 2L is given in the question 25 upon 100 meter. Okay, now it is saying the magnetic strength is, so you can see like M is given here, M is the pole strength, and that is given 14.4 ampere meter. So AM I am taking, right, ampere meter. Okay, rest with the center, right, on a frictionless pivot. It is held equilibrium at an angle of, so it is given something like this with respect to uniform magnetic field. So let us see. So here suppose the magnetic field is in this direction and the magnet is kept like this. So the magnet is kept like this. Okay, and this angle is 60 degree. Let us see. Okay, now it is kept like this, right? This is the direction of magnetic field B vector, and that is uniform. Okay, it is held in equilibrium at angle of 60 degree with respect to uniform magnetic field of induction. So the value of B is also given here. So let us see whatever is given in the question. First I will write it 0.25. That is also in a SI system, so I won't write here. By applying a force at angle of right angle to its axis, right, at a right angle to its axis at a point 12 centimeter from the pivot. So the axis is this. Okay, so from the axis is a right angle like this. Okay, so because right, let us take this is north and this is south. So as you all know, the this bar magnet will try to be in a stable equilibrium and it will try to rotate in this direction, because in the stable equilibrium the direction, right, the north direction tries to align with the direction of magnetic field. So if no force is there, so the bar magnet will try to rotate in this direction, or you can say like clockwise direction, and so it will try to be in align with the magnetic field. Okay, so if you want to make it in equilibrium, you will have to apply some force here. So let us take some force is applied here. That force is F, and the distance from the this axis, it is given here, right? The distance from this axis is given C. How much? 12 centimeter. I mean, like you can say like this is the axis and one force is applied like this, and the distance between these two is 12 centimeter. Okay, and with the application of this force, this is kept at rest. Okay, now so this is given in the question. So now let us solve it. Okay, now it is saying calculate the value of F. So as you all know, okay, so let us find what will be the force due to the magnetic field. First I am trying to find the force, or you can say like the torque due to B vector, let us say, right? So as you all know, the torque due to B vector will be mb sin theta. See, so m is the magnetic moment, so you can easily find here, this is the pole strength and this is the 2L. So capital M will be equal to m into 2L. So see, right, m is how much given? 14.4, and the 2L is how much? 25 upon 100. So this is the capital M. So you can put the value here. So this becomes 14.4 into 25 upon 100. Right, this is the value of capital M. The value of M is given in the question 0.25. So this becomes 0.25 into sin 60. The value of sin 60 you know, root 3 upon 2. So this becomes root 3 upon 2. So this is the torque you are getting due to the magnetic field, and due to this torque the bar magnet will try to rotate in clockwise direction. So this torque will be in clockwise. Okay. Now let us try to calculate the torque due to this force. Okay. So torque due to F, and you can easily see the F, right? This is the axis and this is the force. The distance is how much? 12 centimeter. So the torque will be nothing but F into 12 upon 100. I am taking everything in SI system, and due to this force the torque will be in anti-clockwise direction. Anti-clockwise. Okay. Now due to both these torques, the bar magnet is at rest. So you can say like the magnitude of these two torques must be equal, then only they can cancel each other, and the bar magnet will come at rest. So I can say like, so I can say here, right, you can see as the magnet is in equilibrium, as magnet is in equilibrium, the magnitude of both these torques must be equal. So I can say here F into 12 upon 100 must be equal to this much. So that is 14.4 into 25 upon 100 into 0.25 into root 3 upon 2. So this 100 will get cancelled out. You can see easily from here. Now you can see this 2 will cancel out with this, so that becomes 7 upon 2. Okay. Now you can see this 2 cancel out here, right? That becomes 7.2. This 12 will cancel this, so this becomes 0.6. So now the force you will get here 0.6 into 25 into 0.25 into root 3. So now see how much we will get here from here. Now it gets, so this is 25 upon 100, right? Yeah. Yeah, 12 is, yeah, right. Okay, so now we have to multiply this. So this becomes, see how much we'll get. This will become 15. 15 into this will become 0.25 into root 3. So if you will multiply this 15 into 20, 15 into this, if you multiply, you will get here 125, 15. So you will get here 573. So 3.75 root 3. So this is the value of force you are getting, and that since I have worked everything in Newton, so this will become this much Newton. Okay, now it is saying what will happen if the force is removed. If the force is removed, obviously, right, nobody will be, right, no torque will be there to balance the torque due to field, and so this magnet will try to rotate in clockwise direction, and it will try to align along the field. So you can say like when the force is removed, the bar magnet will start rotating in clockwise direction. Okay. So okay students, I hope you understood this question.